Good day, my amiable viewers, and welcome back to class. As you already know, my name still remains Israel Gwai. Today, we are going to have a look at some topics as it relates to this forthcoming Jamb 2024. Some of these questions we are going to be tackling, they are carefully selected from each topics. It's a form of helping you to know all about that topic. By the time we go through the questions, any question that come from that particular area should be able to tackle it headlong. And again, my dear friends, if you are not subscribed to this my channel, do well to subscribe. You can see I'm trying to meet with the needs of so many of you who are always writing the comment section. Teach us this, review this with us, because as it relates to this Jamb class, is what I saw in the comment section, that I should be able to tackle some questions that we may likely encounter. So even if you don't encounter the exact question, the question will definitely come from these topics. So it's my advice that you study it very, very well so that you do well in your Jamb and have a high performance level. Having said that, let's start the topic. What you have here, there are basically two questions, and from my experience, these ones are from mass and volume relationship, and you cannot do it. There's no way you can write Jamb without having questions under this topic. So this question that I've been carefully selected is what we are going to tackle. What volume of oxygen is produced from the decomposition of 2 moles of potassium trichloride 5 at STP? The way to tackle this kind of question, first of all, you must know the stoichiometry. That is, you must have a balanced chemical equation. So this one is talking about decomposition. You have a KClO3 to give you KCl plus O2. Sometimes they may not give you equation. If they give you the equation, it makes it easier for you. So you can look at it. You have oxygen 2 here, oxygen 3, so it's not balanced. Put 2 here, 2 here, and 3 here. So this is oxygen, 6 oxygen, 2 potassium, 2 chlorine atoms. So this is the equation. You must know how to balance the equation first. Now the question says, what volume of oxygen is produced from the decomposition of this volume of oxygen? From the methods of these questions, I already tackled it under mass and volume. If you go back to my previous video, you see how it's calculated properly. If you go through the video, I don't think you have questions in under mass and volume that you cannot tackle. So you have X here. That's what you should calculate. What volume of oxygen is produced from the decomposition of 2 moles of potassium trichloride 5? This one is so easy. 2 moles. What they are telling you, here you have 2 moles, here you have 3 moles. If 2 moles produce 3 moles, what will these 2 moles produce in terms of volume? To do that effectively, you have to convert this one to volume, because what they are requesting from us is volume. You say 2 moles will give you, this is 3 times 22.4 dm³. You see it? But you always check the question and see if the answers in the options are in dm³. If they are not in dm³, maybe they are in cm³, you now convert to cm³. But let's use dm³ by multiplying by 1000. Let's say 3 times 22.4. You have 67.2 dm³. You see, you say from the equation, two moles of KClO3 equals 67.2 dm³ of oxygen. Therefore, up is 2 moles. 2 moles again of this will give you X. S times 2 moles equals 2 times 2 moles times 67.2 dm³. S equals 2 moles times 67.2 dm³ over 2 moles. This cancel this, give you 67.2 dm³. You see it? The answer remains the same. 2 moles gave you this. 2 moles also give. So some questions may just be direct like that. Like I told you, these are carefully selected. In situation whereby this one is not 2 moles, it's the same procedure. Maybe they say 7 moles. You divide by, you now cross multiply. Use the same method to now be 7 moles of this, then cross multiply. So if your answer is not in DMQ, you check either it should be this or 1000 times 67.2. It will now become CMQ. Let's see what we have. Times 1000 give you 67 points. Let's do it again. 67.2 times 1000 give you C7200. C7200 CMQ, 67,000. So that's what to give you. So that's the solution to this first question. Remember, you don't convert, they must give you two moles. They can give you any other thing. In this situation, we are not calculating mass because they didn't require mass from us. If they are told you what mass, then you have to use the molar mass of this. Most often, they will tell you K equals 39, Ca equals 35.5, O equals 16. Then you solve it accordingly. That's question 1. So let's go to question 2. Question 2 says, they gave us equation. From the reaction above, what is the mass of carbon 4 oxide produced on burning 78 grams of ethyne? Just write it again. 2C2H2. Remember, even if they make mistake in the equation, use it as it is. Don't alter anything. Plus 5O2 to give you 4CO2 plus 2H2O. So, from the reaction above, what is the mass of carbon 4 oxide? You can see this one, we are dealing with mass, S gram. Carbon 4 oxide produced on burning 78 grams of ethyne. We are using 78 grams again. You see it? This is what we produced, what they request for. Then this one is already known. We say 2 times reacting mass times molar mass. Reacting mass times molar mass. So this one is reacting mass equals number of moles times molar mass. That's reacting mass, what you are going to use. Carbon is 12. As you gave to us, carbon is 12. Becomes, put in block form, 12 times 2. Use the molar mass, write this one number of moles. Plus 1 times 2. Block it again. 2 times 24 plus 2. 2 times 26. I think 52, but let us be very, very sure, but I know it's 52. 2 times 26 give you 52. That's good. Then this one, 4 times 12 plus 16 times 2. 4 times 12 plus 32. 4 times 44. Let's see what to give us. 4 times 44 give you 176 gram per mole. But remember, this is for Jamb. If it's for Y, you just follow it sequentially. But since it's Jamb, you can just calculate this directly. It means you have to skip some steps and have 52. Just use this one to multiply this directly and have this. Then this one to multiply 44 and have, because there is no time like that. So you have to be very, very fast. They have, we say 52 gram of C2H2 give you 176 gram of CO2. Under Jamb condition again, you don't need to write this. You just say 52 equals this. This one equals S, cross multiply. You have your answer, go to the next question. But there's no time to waste. So, but this is a process. You have to remove some parts because it's Jamb. But if it's Y, everything here is necessary. So you have 78 gram of this equals S. S times 52 gram equals 176 gram times 78 gram. S equals 176 gram times 78 gram over 52 gram. Gram cancel gram. So you have 176 times 78. Let's see what it gives us. 176 times 176 times 78. give you, divide by 52, give you 264 gram. So that's the mass of carbon dioxide liberated at that particular, liberated from 78 grams of a time. Thank you very much for watching my video. God bless you all.